Welcome back to the 7th episode on Grade 12 Financial Mathematics. In this episode, I would like to discuss with you deviations from the normal patterns. There are 3 different deviations that I would like to discuss. The first one, no payment at the end. The second one, deferred annuities. And the third one, mispayments. Let's start with the first one, which is called no payment at the end. In no payments at the end, we say that in a future value problem, please take note, this is in terms of future value problems. If no payment is made at the end of the last period, please remember that last period can be a month or a quarter, whatever the situation is. We simply calculate the future value, the normal future value immediately after the last payment, and then we apply 1 period of interest to that future value amount, and that will be compound interest. So let's look at this example. Hannes invests 1,000 Rand per month for 4 years. He pays at the beginning of each month. No payment is made at the end of the last month of the 4-year period. The interest rate is 9.5% per annum, compounded monthly. How much money will he have at the end of the 4 years? So let's draw a timeline to illustrate this. So if I draw a timeline for this one, this is T0, T1, T2, and we continue, that is far enough. And then we have T47, T48, just to make sure, everyone happy that that will be T48. Please remember, it's 4 years and it is calculated monthly. So 4 years on a monthly basis means 48 months. Also take in mind that it's stated that the payments are made on the beginning of each month. So that means our first payment will be at T0 because we do it in the beginning of the month, not the end of the month. And then the beginning of the next month, and so it continues. Up to T47, we will not have a payment at T48 because that is the end of the month, that is the beginning of that last month. So no payment at the end. And I hope that you now understand what we mean by this no payment at the end. So that month is where we need to do compound interest. So let's just now write down what is given to us. The monthly payment, which is X, is 1,000 Rand. Our interest rate I is 0,095 over 12. Please take note over 12. Why? Because it is monthly. And then the number of payments. Please remember, within future value annuities, we said before that N is not the number of months, but the number of payments. And the payments are from T0 to up to T47. That is where the last payment is. So there will be 48 payments. Please take note, it's not because of that 48, but because of the fact that the first payment is at T0 and the last payment at T47. Therefore, 48 payments. So now we need to do our future value annuity. So our formula for future value is Fx 1 plus I to the n minus 1 over I. And now I'm just going to substitute. So F is equal to, the X is 1,000 Rand, that is our monthly payment. And then 1 plus I, which is that 0,095 over 12. And my exponent, the number of payments, 48 minus 1, and that we divide by I, which is 0,095 over 12. Now, we can just put this whole fraction on our calculators. And I want you please to check your answer. My answer, 58117 and 67 cents. So the future value at T47 will be 58,117 Rand and 67 cents. You will hopefully agree with me that we are not finished with this question, because we now have the future value at T47. That is where we have the future value. But we want the future value right at the end of the 4 years. So now we need to apply compound interest for 1 month to this amount that we just calculated. So let's do that. Our compound interest formula is A equal to P, 1 plus I to the N. Please take note that N will be 1 because we're only going to do it for 1 month. So my N is 1. The I, the same as in the first part of the question, 0.095 over 12. And please take note, my answer from the first part, that is now my present value, and that is 58117 and 67. So let's now substitute these into this compound interest formula. So we will get this 58,117.67, and we will multiply this with 1 plus I, which is 0.095 over 12, and we're going to do it for only 1 month. So now use your calculator and please check your answer. And my answer for this is 58,577 and 77 cents. So we first calculated the future value up to T47, and then we calculated the amount at T48. There was no payment at T48, and that is why it is a compound interest that we are dealing with. Let's now discuss deferred annuities. When the first payment of a loan is made more than 1 period after the loan was received. Now, I just want to pause there for a moment. You will remember from our discussions on present value annuities that we always need that 1 period, which can be 1 month or 1 quarter, after the loan was granted before we start with the first payment. We can't start with the first payment immediately because then it is a deposit. Now, we refer to this kind of payment annuity as a deferred annuity. When do we call it a deferred annuity? When the first payment is made more than 1, it can be 2 or 3 periods after the loan was granted. Note that the present value of the annuity will still be located 1 period before the first payment. We will apply compound interest to this loan to move it to the same point on the timeline as the present value of the annuity. So let's look at this example. A loan of 500,000 is repaid by means of equal quarterly payments, starting 9 months after the loan is granted and ending 5 years after the loan is granted. The interest rate is 8% per annum, compounded quarterly. And then the first question, what are the quarterly payments? So let's just draw a timeline to see what this is about. Now, our T0, T1, T2, T3, and I'm just going to do a few of them like that. And of course, this last one, I hope you agree, will be T20. Why is that T20? Because they told us these are quarterly payments, and it's for 5 years, and 5 times 4 quarters a year will give you 20 quarters. So this represents a quarter, that is a quarter, etc. Now, the loan was granted, the 500,000, and that is always at T0. So that is where we have the 500,000 loan is at T0. So normally we're supposed to make our first payment 1 period after. In this case, which is a quarter, or for that matter, 3 months after the loan was granted. So that is where our first payment used to be in a normal present value annuity. But because we are dealing with deviations now, this problem, they told us that the first payment was 9 months after the loan was granted. Now, you hopefully will agree that that is 3 months, that is 3 months, and that is also 3 months. So it is 3 months plus 3 plus 3. So this is 9 months. So that is where the first payment will be right at T3. And we always want our loan, our present value, we want 1 period before the first payment. So we would like our present value to be at T2. So that means now that we need to grow this loan, for 2 periods, or for that matter, 2 quarters. Now, if we say we grow the loan, you will hopefully agree that there are no payments. So that means it's compound interest. Because if we delay our payments, that loan of 500,000 will still gain interest. And we now need to grow that loan up to T2 so that we know what the loan is when we start with our payments 9 months after the loan was granted. So this is a compound interest problem, and it's 1 plus I to the n. The I, you will agree, given to us 8%, and it's 0.08 over 4. Please take note, it's not 12, because we are so used to write down divide by 12, because most of the time it's monthly, and this one is quarterly, so you will agree we divide by 4. So let's substitute, and we find this new present value. So the loan is 500,000, and that loan we need to grow with the interest rate of 0.08 over 4, and we're going to grow it for 2 quarters. Remember, that n represents now the number of quarters, and that is 2, because we need to grow the loan up to T2. So easy now to find this answer by using our calculator, and I hope you agree. My answer, 520,200, or 520,200. So the loan was originally 500,000. We didn't start to make payments, and now we need to grow the loan up to T2, and at T2 this loan will be 520,200. Let's now look at the second half of this question. Remember, they ask us to find the quarterly payments. What we did now is we only calculated the present value at T2. We still need to find the quarterly payments. So let's do that. So to find the quarterly payment means we must calculate X in our present value annuity formula. So that formula is P X 1 minus 1 plus I to the minus n over I. Now, we are looking for x. The P amount is what we calculated just now, and that is the 520,200. That will be our P, or our new present value. X is what we are looking for. I, the same as what we used in the first half of the question, 0.08 over 4. And then what we need to think about is how many payments will there be. Now, you will agree with me if I go back to the previous screen that we said there will be 20 quarters, but please take note, the first 2 quarters there were no payments. So that means n will be 20 minus 2, so that means 18 payments only. So let's now substitute. So we say 520,200. X is what we want to calculate. 1 minus 1 plus I, 0.08 over 4. My exponent is minus 18 over 0.08 over 4. I'm sure you still remember during our discussions on present value annuities, and the question was to calculate X. How did we find X? We say that X is equal to that 520,200. We multiply that with this denominator, 0.08 over 4, and we divide with that whole bracket above the line, which is 1 minus 1 plus 0.08 over 4, and the exponent minus 18. So now on our calculator, we put this whole fraction on, and I hope you will agree with my answer for X. I've got 34,698 and 43. So please take note, this is the quarterly payment. So that is what we need to pay per quarter. Please take note, it's not per month. So that is the payment to pay back this loan starting 9 months after the loan was granted. And we want to pay it within a time frame of 5 years. So we're going to make 18 payments, quarterly payments of 34,698 Rand and 43 cents. Let's now look at the B part of the question on deferred annuities. Now, in this question, they ask us, what is the outstanding balance? And you will remember that was one of our previous episodes, how to calculate an outstanding balance on the loan directly after payment number 6 has been made. Now, as you can remember, that when we want to find an outstanding balance, we need to have a look at the future value annuity for the payments made. We also need to look at the value of the loan in terms of compound interest, and we find the difference. But before we do so, let's just draw a timeline just to see where this last payment will be. So on a timeline, T0, T1, T2, T3, and let's put down T4, and somewhere we will have T8, T9, and so on. So as you remember, the loan of 500,000 was at T0. We started our first payment at T3, and we calculated the the new present value, or we grow the loan, and that was 520,200, and that was at T2. And then we started to make payments as from T3. So at T3, we've made a payment, let's call it X, and we continue to do so right up to T8. We're going to pay the X amount. And remember that X we calculated in the first part of the question. So that was the quarterly payment. So let's just now see. Remember the question said after payment number 6. So we can't look at T6 because our payment started at T3. So we have a payment at T3, at T4, T5, T6, T7, and then T8. So maybe it will be easier if I just put those in as well. And then it's easy to see where we will make these payments. So we're going to make 6 payments. So it's not up to T6, it's 6 payments because we started at T3. So there's the payment number 1, 2, 3, 4, 5, 6 at T8. So that is our 6 payments. So what we are looking for is, we are looking for the outstanding balance right at I indicated now T9, but at T8. So that is where we want the outstanding balance, at T8. Now, let's just write down the formula for outstanding balance. So outstanding balance is equal to, first of all, the compound interest to the n minus X, and now the present value annuity, 1 plus I to the n minus 1 over I. Now what I would like to do is to call this exponent M. You will notice that normally we set within an outstanding balance, those two exponents will be the same, this one and that one. In this problem, it is not going to be the case, because we want to take the 500,000 right up to T8, and then we want the future value from T3 up to T8. So let us now just see what we're going to substitute. Our M, because that is our future value, will be equal to 6 payments. The N in the compound interest will be 8, because we're going to grow that loan of 500,000 Rand for 8 months, right up to T8. We're going to grow that loan. And we calculated X already in the A part of this question, and that was the 34,000 Rand that we spoke about before, 34,698.43. So let's now substitute. So our outstanding balance is going to be our P, that is the loan, the original loan of 500,000, 1 plus my interest rate, still the same as in A, 0.8 over 4. We're going to grow this loan for 8 months. Please take note, the loan was granted at T0, and we now want to grow it right up to T8. From that, we're going to subtract our X, 34,698.43, and then we say 1 plus 0.08 over 4. Our M, that exponent, is 6, and you will see this is now not the same as what we did in our previous episodes, 0.08 over 4. So I just want to emphasize that that exponent is 8 and that exponent is 6. Reason for it is we are dealing with a deferred annuity. So we started with our payments later. And that is why we have lesser payments than the number of months we want to grow this loan. So now we put this onto the calculator, and the outstanding balance, according to my calculation, is 366,947.80. Outstanding balance 366,947.80, or for that matter 366,947 rand 80. That will be the outstanding balance after payment number 6, or for that matter at D8. The third deviation from the normal pattern is what we call mispayments. Now, mispayments, exactly what the word says, is when we are paying back a loan and for whatever reason, financial difficulty, or maybe someone loses his job and he can't continue with his payments. And you make then an arrangement with the institution, and he will take what we refer to as a payment holiday. And he will stop payments, say, for 3-4 periods, and then he will continue paying. So let's now look at what this is all about. In mispayments, we say it can happen that due to financial difficulty, a person is unable to make payments on a loan for some time. Now that sometimes all depends on the situation. As soon as the person's situation improves, payments will resume. The new payment will be higher since fewer payments will now be made in total. So I hope you understand that we will have lesser payments because there are a few payments that we missed. Also, the loan has accumulated interest in the time when no payments were made. So right up to the time when we've made the last payment, we then need to apply compound interest on the loan up to the period before we resume payments. To calculate the new payment, we calculate the outstanding balance immediately after the last payment was made, before payment ceased. When we then apply compound interest to this outstanding balance till one period before the payments resume. Remember, in terms of present value annuities, we always want the present value one period before the payments resume. The result is the present value of the new annuity consisting of all the remaining payments. So let's look at our example. In this example, James takes out a loan of 100,000. He is to repay this loan by means of equal monthly payments, starting 1 month after the loan was granted. And you will agree that is our normal situation. The loan is to be repaid over a period of 4 years at an interest rate of 10% per annum compounded monthly. What is his monthly payment? Now, you will agree with me that there is nothing strange about this question. We just want to work out we are just working with a normal present value annuity, and we want to see what his monthly payment will be. So let me just draw a timeline and say T1, T2, T3, and it continues like that, and this will be up to T48. I hope you agree with the 48 there, because it's 4 years and it is monthly. So that means 4 times 12. Now, the loan was granted right at T0, that is the 100,000. Then he started to pay his loan 1 month after. 1 month after the loan was granted. And you will agree that is the gap we were talking about before. And every month he will make these payments right up to T48. So you will agree with me N will be 48. There will be 48 payments to repay this loan. That is from T1 to T48. Our interest rate was given at 10% per annum compounded monthly. So that will be 0,1 over 12. And our present value, that means our loan is that 100,000. Remember, this is a present value annuity. Our present value annuity formula, P equal to X, 1 minus 1 plus I to the minus N over I. And now we substitute to calculate X. So that means I know what my P is, because I already said P is 100,000. So that is 100,000. And X is what we would like to calculate. So 1 minus 1 plus I 0,1 over 12, because it was monthly. N represents the number of payments, so it's minus 48, and over I 0,1 over 12. Now we multiply both sides with the denominator, we divide with a whole bracket, and that will give us our monthly payment of X. So we will have 100,000 times by 0,1 over 12, and we divide by 1 minus 1 plus 0,1 over 12, my exponent minus 48. And now, when you use your calculator, you will hopefully agree with my answer of 2536.26. So the monthly payment, that was the question, what is the monthly payment, will be 2,536 Rand and 26 cents. So now we are ready for the B part of this question. Now in this part, they say that James lost his job and is unable to make the 20th, the 21st, and the 22nd payments. So payment number 20, payment number 21, payment number 22. So there are 3 payments that he's going to miss. Remember, we are busy with deviations from the normal pattern, and this one we discuss now is called mispayments. So he's going to miss 3 payments. He wishes to still repay the loan by the end of the original 4 years. What is the new monthly payment now? All right. To discuss this, let's just draw once again a timeline. So if I draw my timeline from T0, and that is T1, T2, T3, you remember we said that it goes up to T48. So somewhere here, we will have T19, T20, T21, and T22. We can even put in a T23. Now, the reason why I've done this is because of the fact that he missed 3 payments. Now he missed that payment, he missed that one, and he missed that one. Those are the 3 payments he missed. So the loan was granted at T0. That was the 100,000 Rand loan. He started with his monthly payments, and we already calculated that monthly payment as our X amount, which was 2,536 and 26. Please remember, I still the same as in A, and that is 0,1 over 12. And now what we need to do is we first of all need to find the outstanding balance at the last payment. Now he's going to make payments at T1, T2, T3, continue like that, and his last payment will be at T19. So this is where we want the outstanding balance. So what will be still outstanding on the loan after this last payment at T19? So let's now look at this outstanding balance. So we're going to do the outstanding balance at T19. So our formula for outstanding balance is compound interest, 1 plus I to the n, subtract future value annuity, 1 plus I to the n minus 1 over I. So let's just substitute this now. And we say our outstanding balance, the P, you will agree, that was our loan that we now need to grow up to T19 with an interest rate of 0.1 over 12. And I hope you will agree with me that exponent will be 19. Subtract our monthly payment to 53626. 1 plus I 0.1 over 12. The exponent here again will be the same as that one because he made 19 payments. From T1 up to T19 will give you 19 payments. So that is our N. So it's not like in the previous discussions where in some cases where we have a deferred annuity where the two exponents are not the same. In this problem, they will be the same, and 0.1 over 12. Now, we put this onto our calculator, and then we calculate this outstanding balance at T19. Now, according to my calculation, my answer is 65,099.21 cents. So 65,099 Rand and 21 cents. This is the outstanding balance at T19. Now, please take note that he missed now 3 payments. So that means we need to grow this loan. So this is now the present value. The new present value is this outstanding balance. That's 65,000. We now need to grow it up to one period before the first payment or the new first payment that we're going to calculate just now. So we're going to apply compound interest, and I hope you will agree with me. We're going to apply compound interest to this for 1, 2, 3 months. Because we want the loan right here, because our first payment again is at T23. That will be the new payment after interest was added. So let's now just add 3 months of interest. So we say A is equal to P, 1 plus I to the N, and we substitute. This P is, of course, this amount that we just calculated, because that is the loan right at T19, 0, that was the outstanding balance. And we're going to add interest to this, and the interest rate still the same, and we're going to do it for 3 months. Now, my answer for this question here is 66,740.29 cents. So as you can see, that this loan now, this outstanding sort of the present value of the loan, you will notice is slightly more than the one that we calculated before. Reason being, that was the outstanding balance at T19, and now this is our present value at T22. So that is where we have this loan now. So we're now going to start with a brand new calculation on present value. So we're going to look at this amount as our loan. We're going to calculate X, and we still need to determine how many payments he's going to make. So let's do that. So our present value annuity formula, 1 minus 1 plus I to the minus n over I. You will remember X is what we are looking for. Remember the question was what will be the new monthly payment? Our present value is that amount at T22. That was after we added 3 months interest to the outstanding balance. That was 66740.29. That is our P. I is still the 0.1 over 12. Now, how many payments will there be? Now, please, if I go back to the previous screen, the first payment will be at T23 and the last payment at T48. Now, to make sure that you don't make a mistake, an easy way to find the number of payments, you say 48 minus 23 and you plus 1. And I hope you will agree, if you work that out, you will notice that there are still 26 payments. So he's going to still need to make 26 payments of the X amount that we're going to calculate to pay off this loan of 66,740. So it's always an easy way to work it out is to take the last month, 48, minus the month where you start your payments, you subtract and you plus 1. So let's now substitute. So I say 66740.29. X is what we are looking for. 1 minus 1 plus I, 0.1 over 12. And then my N, remember the negative, over I, 0.1 over 12. Now, we've done it a couple of times already to solve for X. So we say X is equal to 66,740.29. We multiply by the denominator and we divide with that whole fraction, 1 plus 0.1 over 12 to the exponent of minus 26. All right, now we use our calculator and please check your answer against mine. My answer, 2865 and 69 cents. So what is the meaning of this answer? This is the new monthly payment. So this new monthly payment, 2,865 Rand and 69 cents. If you go back to the A part, you will remember the payment before he missed the 3 payments was 2,536. So you will notice that the new payments are a little bit more, around about, I want to say about maybe 300 Rand more. And that is because of the fact that there are 3 lesser payments, as well as the interest added those 3 months that he missed his payments. I hope that this discussion on deviations on the normal patterns are now much easier for you.